This video will explain Chapter 7 of Physics Form 5, the Quantum Physics. And you are with me, Teacher Yusrina Abdul Hamid. To explain the initiation of quantum theory of light, we first need to understand the electromagnetic spectrum, electromagnetic radiation, and also the black body. So what is electromagnetic spectrum? Electromagnetic spectrum is a continuous spectrum which consists of 7 types of waves with different frequencies and wavelength. Continuous means there is no gap or boundary throughout its wavelength range. So as you can see, this is the electromagnetic spectrum. So we have in this spectrum the radio waves, microwaves, infrared radiation, the visible light, and then we have ultraviolet radiation, X-rays, and also gamma rays. So student, you have to try to memorize these waves and arrange them according to their wavelengths and also the frequencies. So you can use the acronym Ready, may I visit your ex-girlfriend? So ready, may I visit your ex-girlfriend? So radio waves has the longest wavelength and gamma rays has the shortest wavelength. So higher wavelength means the waves has a lower frequency and also the vice versa. And then in the spectrum, there is also a narrow portion of wave which is known as a visible light. It is ranging from 400 nanometers to 750 nanometer. And again, this is also a continuous spectrum, which means we cannot see any gap or breakup between any two colors. This spectrum is formed when a white light disperses through a prism. And there are 7 component colors in this spectrum: the red, orange, yellow, green, blue, indigo, and violet. And again, you have to memorize all of the colors in this spectrum. It is also known as the rainbow colors. What is electromagnetic radiation? So all objects emit electromagnetic radiation. Cool objects emit waves with low frequencies such as radio waves and microwaves, while hot objects emit waves with higher frequency such as visible light, ultraviolet radiation. Do humans also emit electromagnetic radiation? Yes, humans also emit radiation. And humans gives off mostly infrared radiation with lower frequency than the visible light. Let's proceed to black body. A black body is an ideal body that is able to absorb all incident electromagnetic radiation that falls on it. And a black body does not need to be black. When a black body reaches thermal equilibrium inside its containment, which means when it has a constant temperature, it emits electromagnetic radiation, which is also known as a black body radiation. The radiation emitted forms continuous spectrum and is unaffected by the nature of the black body surface. Now let's look at this simple example of black body. We can imagine a black body as a cavity with a small hole. Any light incident upon the hole goes into the cavity and undergoes a very large number of reflections of the walls of the cavity. No light is reflected out, so we can say that all the lights have been absorbed by the walls of the cavity. So we can only see all black color if we look into the hole. This animation can help you to understand how light is absorbed by the wall of the cavity. When a black body is at a uniform temperature, and is in thermal equilibrium with the wall of its own cavity, let's say 310 Kelvin, the black body will emit radiation from its surface at that same temperature. This radiation is called as thermal radiation. Thermal radiation is electromagnetic radiation, and thermal radiation depends on the temperature of a black body. At a fixed temperature, a black body emits radiation in many frequencies and wavelengths. The intensity of the emitted wavelength can be detected using a spectral detector like a bolometer. These are few examples of black bodies in daily life. The first one is a thermographic image of human body. The second one is the thermal radiation in light bulbs. And the third one is a heating element in heater. So we have discussed on electromagnetic spectrum and radiation and the black body. And I will continue with the graph of radiation intensity versus wavelength and also the ideas that spark the quantum physics theory in my next video. See you there. Bye.